number tile is selected and the spinner is spun, what is the probability that both will be a vowel? So if you're looking at your tiles, again, what are vowels? A, E, I, O, and U. So looking at your tiles, how many options there do you have that are vowels? 2. Out of how many?
4.
Okay, so somebody reduced that already for me, and they said that's the same as 1/2. Okay, so that is the probability of your tiles. And it's like our fundamental counting principle. We're going to multiply again because it says and. This spinner over here, how many options do you have that are a vowel?
You have 1.
Out of?
3.
So 1 times 1 is?
1.
2 times 3 is?
6.
So we have 1/6 probability, which is the same as 1700ths, which is the same as 17%. Okay, if we looked at the way the book did it, they made a tree diagram. Okay, so on my tiles, I have 4 options. I have G, B, E, and A, right? Even if I picked G, on the spinner, I still have the options of A, B, and C. Even if I picked B, I still have the options of A, B, and C. E, I have the options of A, B, and C. A, I still have A, B, and C, right? Doesn't matter. So then this is my sample space, all listed out over here. So then I would go through and see how many of them have both vowels. So is GA both vowels?
No.
Is GB both vowels?
No.
GC?
No.
BA?
No.
BB?
No.
BC?
No.
EA?
Yeah.
EB?
No.
EC?
No.
AA?
Yes.
AB?
No.
AC?
No.
Okay, so I had 2 options out of how many total sample space?
12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Can I reduce that fraction?
1/6.
By 2, which gives me 1/6.
1/6.
Is that what we found?
Yeah.
Yes. If you like drawing the tree diagrams and writing out your sample space, that's great. It's a great visual. If the counting principle makes sense to you in the lesson before and you want to apply it to our lesson now, that's fine with me as well. Questions? Okay. Let's go over to example 2 then. Method 2 is the one that we did in the start.
Oh, yeah.
Okay, so the spinner and number cube shown are used in a game. What is the probability of a player not spinning blue and then rolling a 3 or a 4? Okay, so first of all, we need our spinner to not be blue. How many options on this spinner do we have that are not blue?
4.
4, right? 1, 2, 3, 4. 4 out of our total number, which is 5. Can that be reduced?
No.
Okay, but we also need, so multiply, because it says, and rolling a 3 or a 4. On a dice, how many options do you have that are 3 or 4?
2.
3 or 4, right? You have 2, 3 and 4. Out of how many?
6.
Okay, would you like to reduce something first?
Yes, 1/3. We can make that one.
So you're dividing both the top and the bottom by
2.
So you get 1/3, right? Okay, so then I can actually multiply. 4 times 1 is?
4.
5 times 3 is?
15.
And that is reduced. So I would type 4 divided by 15 in my calculator. Please do that.
No, 27.
So you got 260 what?
It was just repeating.
So 266,000. I just want to refresh us on rounding. So if we round to the nearest hundredth, this 6 would tell my other 6 to go up.
7.
So that's how they got 27 hundredths, which is the same as 27%. Is that likely or unlikely?
Unlikely.
Unlikely. Okay. Got it A. I'm going to read it to you so that we understand. It says a game requires players to roll 2 number cubes, so 2 dice, to move the game pieces. The faces are labeled 1 through 6 like a dice. What is the probability of rolling a 2 or 4 on the first cube and then rolling a 5 on the second? Okay, so the order does kind of matter. So on the first probability, they want 2 or 4. On the second probability, they want 5 only. Okay, try that on your own. Check with your elbow partner when you're done. Bananas and 5 apples in a fruit basket. Ignacio? Is that how you say it? Ignacio, I think. Selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. Okay, so how many, first of all, how many total fruit do you have there?
You have 16.
How'd you do that?
You add 4 plus 7 plus 5.
So 4 plus 7 plus 5 will give me my total number of fruit,
16.
which is 16, right?
Yeah.
Okay, so we know our total. How many apples do we have for Ignacio to choose? 5. Okay, so Ignacio grabbed an apple, took it out. How many apples are left now?
There'd be 4.
There'd be 4, right? So we have 4. How many total fruit are left?
There would be
15, right? Because if I took out an apple, I have 1 less apple and I have 1 less total fruit in the basket. Okay, could I cross reduce anywhere before I multiplied?
Yeah.
Where?
Yes. You get 16. 4 is 16. Yeah.
The 4 becomes a,
Yes. 1.
the 16 becomes a,
4.
the 5 becomes a,
1.
the 15 becomes a.
3.
So I just cross reduce. Okay, if you don't cross reduce first, you'll just have to simplify at the end. 1 times 1 is?
You get 20 over 240.
4 times 3 is?
12.
So 1/12, which is the same as what as a decimal?
8%. 8%.
Are you sure?
Yeah.
So it's 8 hundredths,
Yeah.
which is the same as 8%. So that would be it. It changed our probability for the second because I no longer have that apple or that extra piece of fruit in the basket. Okay, so it's dependent of what happened the first time.
So you basically subtract.
We're all of our fruits back in our basket. How many bananas do you have to choose from in the first pick?
7.
7 out of how many? 16. Okay, I picked 1 banana out. How many bananas are in there now?
6 out of
6. And how many total fruit are there now?
15.
Because I picked 1 out, so there's 1 less in there. Could I cross reduce somewhere?
Yeah.
Yes. My 16 becomes a
Oh, 8.
8 because we're dividing by 2. My 6 becomes a 3. We divided both 6 and 16 by 2. So 7 times 3 is,
21.
and 8 times 15 is?
It is 120.
120? What is that as a decimal? Carter, thank you for doing it.
It is 175,000. So it'd be 18%.
1800s, which is the same as 18%. So the first banana is pulled out, so then I have less to choose from for my second option. Shmir, are you writing this down? Okay, so C is a little bit different. C, we're restarting, so all our fruit's back in our basket. How many oranges do you have to choose from for the first draw?
4.
Out of how many?
16. You can reduce that.
What do you want to reduce it to, Levi?
1 more.
Okay, so we divided the top by 4, got 1. We divided the bottom by 4, got 4. Okay, then I pull an apple. How many apples do I have in my basket? I have 5 apples because I didn't pick one of the apples the first time, so I have all my apples still in the basket. But how many total fruit do I have?
15. Which is 1 Wait, you can simplify 1/3.
Okay, so then they said they wanted to simplify that again. 5 divided by 5 is 1. 15 divided by 5 is 3. Okay, so now I can multiply straight across. 1 times 1 is?
1.
4 times 3 is?
12.
And we already figured that out was the same as 8 hundredths, which is the same as
Is this just
8%.
This is fun. Is that real? I don't know. Is that like?
is C, the letter C, or where it's